Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. In this session, we are going to learn about the basics of Prolog. That is what we already started in the previous sessions. In this session, we are going to see about the backtracking and data types of Prolog. Let's see what is a backtracking. This backtracking is used in several areas. It means in the designing algorithms and solving complex problems. We are already aware of this backtracking. It will explore all the solutions, and it will goes to the based upon the conditions. It will start exploring the one by one solution which is up to that particular problem. Then it will take that only that solution. For example, if you take water jug problem in AI, then it has to be two jugs. One is contains 3 liters, another one is contains the 5 liters. So we'll have the multiple solutions to that problem. So whichever the solution is costing less and taking the less amount of time, then we will go with that solution. Based upon the conditions and scenario, we will consider that solution out of all the solutions. Once if you reach one of the solution and it is taking much time, then again we'll go to the backtrack and we'll go to another solution if you are having multiple solutions. Okay, so let's see what is a backtracking in Prolog. Backtracking is a procedure in which Prolog searches the truth value of different predicates by checking whether they are correct or not. The backtracking term is quite common in algorithms designing and in different programming environments. In Prolog, until it reaches a proper destination, it tries to backtrack. When the destination is found, then it will stop that going on finding the next one. Okay, let's see here. Here we are having the tree structure A, B, C, D, E, F, G. So E is the root node and G is the destination node, source and destination. We need to reach to the destination G. So how it will start? It will start from A to B. Then it will compare with the B equal to G or not. No, it is not a G. Then again it will goes to the next node, because when it will goes to the A, if you compare A equal to G, it is not a destination node. So it will don't go to B to A. Already it is coming from A to B only. So next it will goes to the next node B to D, and again it will compare D equal to G. No, it is not a destination node. Then it will trying to search for the D leaf node. So there are no D leaf nodes to the D. Then it will goes to the again backtrack to the D to B, because there is no another nodes here to find the G. So it will goes to backtrack to B, and again it will goes to the next node of the B. What is the next node? E. Then again it will try to compare E with the G destination node. No, it is not a G. Then again it will backtrack. After that again it will search for another node of B. There are no nodes are left to search for the G. So again it will backtrack now, and from A it will try to search for the next nodes other than the B. So here we are having C. Then it will goes to the C node. Again it will compare C equal to G. No, it is not a destination node. Then again it will goes to C to F. Again it will check for the condition F equal to G. No, it is not. It is also not a destination node. Then again it will backtrack to the C, because there are other nodes are there in the F. So it will backtrack. Again it will goes to the next node of the C, that is the G. Again it will check for the condition G equal to G. Yes, it is the node. Then it will stop the backtracking or stop finding the other nodes, because it reaches the destination node. In this way it will execute the backtracking in Prolog. First it will explore the one by one node. Each and every node it will check for the condition whether it is a destination node or not. If it is a destination node, it will stop searching. If it is not, it will backtrack, and it will explore the remaining nodes also to find the destination node. So that is what explanation we are having. So suppose A to G are some rules and facts. We start from A and want to reach G. The proper path will be A, C, G. But at first it will go from A to B, because this is the path. When we know that thing, when we reach that path, then only we will get to know A, C, G is the correct path. But before that, we don't know how to reach the G. So we need to explore from left to right each and every node from top to bottom. So first it will go from A to B, then B to D. When it finds that D is not the destination, it backtracks to B, then go to E and E. Backtracks again to B, as there is no other child of B, then it backtracks to A, thus it searches for G and finally found G in the path A, C, G. That dashed lines are indicating the backtracking. So when it finds a G, it stops exploring the remaining nodes, because G is the goal node. So now consider a situation where two people, X and Y, can pay each other, but the condition is that a boy can pay to a girl. So X will be a boy and Y will be a girl. So for this, we have defined some facts and rules. Let's see. The knowledge base is boy Tom, boy Bob. When Tom or Bob are there, then the Tom or Bob, any one has to pay. If the Alice or Lily, both are girls, so they need to pay. That is the scenario. Let's see once again. Now consider a situation like where two people, X and Y, can pay each other, but the condition is that a boy can pay to a girl. So X will be a boy and Y will be a girl. If Y will be a girl, then X has to pay. That is the scenario. For that, the condition is pay X comma Y, implied when it will pay when X is a boy, Y is a girl. This is the condition. So look at here, pay X comma Y, X is a boy and Y is a girl. When X is a boy, then there are two choices. One is Alice, another one is Lily. Then only Tom will pay. Next again, another note, that is a Bob. When girls, Alice or Lily, then Bob has to pay. As X will be a boy, so there are two choices, and for each boy there are two choices, Alice and Lily. Now let us see the output, how it will be backtracked. So to know how it will be backtracked, this is the command. Within the parentheses, within the square brackets, we need to write the backtrack command. Then it will backtrack how it will be processed and everything. We'll see in the execution part. Let's see execution. So open Swi Prolog. So file, new, backtrack.pl. Okay. I'm just copying the program. Control C. Pay X comma Y. Okay. Now if you want to know how backtrack, the process is executed. Tom, X, Y equal to Alice. Again, when we are the semicolon, then it will search for the next one. So X equal to Tom and Y equal to Lily. Next, when X equal to Bob, Y equal to Alice, again X equal to Bob and Y equal to Lily. In this way, it will be processed. Okay. So look at here, x equal to Tom, y equal to Alice, again semicolon to go to the next node, x equal to Tom, y equal to Lily, and x equal to Bob, y equal to Alice. For each and every x, there are two choices, Alice and Lily. When Bob is x, y equal to Alice, y equal to Lily. When x equal to Tom, again two choices, y equal to Alice and y equal to Lily. Okay. So how it will be backtracked? First pay and call boy. Next boy is Tom. Girl, it will search for girl. Girl is Alice. Again pay Tom and Alice. How it will be exit. Next again pay Tom, Alice. Girl is Alice. Girl is Lily. In such a way it will be backtracked each and every value in that program or a database. Okay. So this is how it will be backtracked. It will explore all the solution and it will reach us to the one of the solution. If it is up to our condition, then it will stop executing. Otherwise, again, it will explore the remaining. Next, types of Prolog. So Prolog is used to provide the tuples, list, numbers, atoms, and patterns. Let's see the simple types. This type of Prolog is implementation dependent. So here Boolean, true or false, variables which are represented in the form of capital letters, capitals. So whenever we will write John, Mary, these are not variables, these are called as terms or constants. Terms are constants. Whenever we will represent with the capital letters, then only which are called as variables. Next, integer. Next, atoms are constants and real, that are floating point values. So next one is composition types. The distinction between data and program are blurred in Prolog. In the argument, data is often passed to predicates. In Prolog, the most common data structure is list. Lists are much like a stack in which we can only sequentially access the list of elements, and much like the array in which we have list of elements in sequentially. Let's see this one, list mango, grapes, and orange. So otherwise we can write author name Abby, Anthony, title of that book, and data when it is year of publishing. Like that we can write the composition. Not only one data type, we can mix with the multiple data types here. Next, predicates. The user has to determine the parameter type because Prolog is a weakly typed language, because on the time we will give the type of variable. To determine the parameter type in Prolog, the following are the predicate can be used. Atom A. A is an atom. Atomic A. A is a number or an atom. Number N. N is an integer or real value. Where V is a variable. Non-variable. NV is not a variable. Integer I is an integer. Real R is a floating point value. In such a case, we can know the what kind of variable it is. Okay. So in this session, we have seen variables, types of data, composition type, and backtracking, how it will performed. We have seen data types and backtracking in this session. Thank you.